After yesterday's first partition here, see the value of j we need to return. Okay, let us go back to this program here. This particular line was executing. So this is a function. So we come to this partition function. We execute these set of code. Okay. The last statement that we have is return j. So the value that we had got was 4. The value that we had got for j was 4. So 4 is going to be returned now. Which function? To this partition. So I've just updated the value here, 4. Now, after this, we have a statement that is again a function, that is quick sort. See observe the names here, quick sort. So this function quick sort is calling itself. Right? Now, what are the values that we need to pass? Array, we need to pass the value of low. Let us have a look at the value of low here. The value of low. Then we need to pass the value of j minus 1. Okay, I update the value of j here, that is returned as 4. So now j minus 1 is going to be equal to 3. Fine. Now quick sort, this function, where the execution or this cursor of execution will go, it will come to this function again. See, when we came to partition function or this line, this function started the execution. Now we are at this line, quick sort. So where is the function? The function is here. So the function will start its execution. Now what values will be passed here? They are going to be a, low and high. The value of high, that is here, is replaced by j minus 1, which is 3. Now again you need to check, okay, if low less than high. So you check for 0 less than 3, which is true. So again we will go inside this and again the partition function is going to be called. Let me update the value here for high. What will it be? What will be the value of high? Will it be 4 or will it be 3? It should be 3. Okay. The value of high will now be 3. So this function is called again. We go inside this and repeat the same steps. So pivot we know will be equal to a of low. We need to update here now. Let us write this partition function also. The values that are called is a, 0 and 3. Okay. So only this array we will sort. What will be the value of the pivot element? A of 0. Right? So A of 0 is 11. Let me update it as 11. Next thing, we have I is equal to low plus 1. What is the value of I? I is going to be equal to 1 because value of low is 0. 0 plus 1 will be 1. What about the value of j? Okay. Then flag we have to update it to 1. Next we come to this inside while loop. We check for a of I. Now what is going to be the value of a of I? 10. So it will be 10 less than what? 11 is a pivot element, and what is the condition again? I less than j. Okay. So where is the index I? 1. J is at 3. It will be 1 less than 3. Is it true or false? True. Both are true. It is going to be true. If it is true, it is while is true, we need to increment I. So what will be the updated value of I now? 2. So I is going to be updated to the value 2. Next, are we still in the while loop? Yes. So this time, what will be value of A of I? The value of A of I less than pivot and I less than J. So let us check for A of I. 9, 9 less than 11 and less than 3. Is it true? Yes. If it is true, we need to increment the value of I, which becomes 3. What will be the next set of execution again? Again the while loop. Let us increment the value of I here. Check for the value of A of I now. 18. So it is going to be 18 less than 11 and 3 less than 3. The first condition itself, 18 less than 11 is false. So even if you do not check for this, it's fine, right? Because AND operator means both should be true or both should be false. This will be false. We need not increment the value of I. Next, we have this while loop. Check for A of J is greater than pivot. Let us have a look at A of J. 18. Correct? So A of J is going to be 18 greater than 11, which is true, which means we need to decrement the value of J. What will be the decremented value? 2. So J is decremented. Next, are we still in the while loop? Yes. What will be the next A of J? 9 greater than 11. False. No need to decrement. We executed this. This is false now. So next we have if I less than J. What is the value of I and J? Have a look here. 3 less than 2. 3 less than 2, which is false. So if this statement is false, we need that means else flag we have to set to 0. Let us update the value of flag here. Next, what is this code for? Swapping which two elements? J and pivot. Not J and I, it is J and pivot. What is the jth element? 9 and pivot is 11. Correct? I'll update it here itself. This is going to be 11 and this is going to be 9. Okay. Is your left subarray sorted? Yes. So for homework, you can continue with these iterations and see when it stops executing and also try to sort this right side of the array. Fine. This is about quick sort. Any doubts here? No doubts? We'll proceed to the next concept. Okay, the next program that we have is selection sort. Okay, let me get the program. Now, how selection sort works? How selection sort works? Have a look at the array elements. Tell me, are they in sorted order? Then, what is the size of the array? 6. Size of n. is 6. Now, how this selection sort works? The minimum element is 10. 10 is going to be put in the lowest position. Means 10 will be put in the index 0. In the first comparison, the lowest element will come to its lowest position. That is 10 will come here. Next lowest and 40 is going to be put here, okay? And 40 will be put here. Now, which is the next lowest element? 20, which is already in correct place. Next lowest element? 30. So, 30 will be put here and 60 is going to be put here. Fine? Compare this with your bubble sort. How does bubble sort work? The greatest element is put to the last place. In your selection sort, the lowest element we are putting it in the lowest or the first place. So for comparison, we directly just can't pick the lowest. No. How do you understand that an element? How do you understand that 10 is the lowest? When you compare it with 40 or when you compare it with 20, right? You need something to compare. Then only you can understand that one element is less. Now, for example, all of you must have played cards, patte. Now, you know that the numbers, like when you randomly put the deck of cards and you try to pick one particular leaf there, you look at the element. Say the element is 4. You just, the first card, okay, I just want to hold it. Next leaf I pick and the next leaf number is going to be equal to 5. Now, if the element is greater than 5, how do you arrange when you try to hold it in the hand and when you try to arrange? If this is 4, I try to put 5 here, no? After 4. I will not put it before. So, when I am putting it after 4, what am I doing? I am trying to compare 4 with 5. And I know that 5 is greater, so I am putting it afterwards. Suppose I pick another leaf. This time the leaf is 2, which is lesser than 4, also lesser than 5. We know that now 4 and 5, both the leaf that I am holding are sorted. 4 is here, 5 is coming here. They are sorted. Next I have 2. Where will I place it? No, because I know these are already sorted, which means I am comparing it with 4 and then I am trying to put it before 4. So likewise here when I say we need to put the smallest element in the first place. So I need it to compare with something. So I will compare, likewise I am going to compare first 2 elements, then I will compare next 2 elements and then we put it in the lowest place. Understanding? We directly see this with the help of the program tracing itself. Let us have a look at the code. So we are familiar now with these lines. Okay. See here also you have a variable called as min, because we need to find the minimum element or the lowest element, and a variable called temp. Temp is again for swapping. Okay. So here we try to ask the size of the array, we try to accept the elements. Then this is the main logic. We have a loop, outer for loop. Within that, we are initially just assuming that the minimum element will be equal to the value, that is to the index of I, that is 0. Means what I am assuming, if I have to look like this, I am assuming this is going to be I is equal to 0. So I am assuming that 40 itself is my minimum element. This is my first assumption. Okay, because I need to compare it with something. Then we have another inner for loop. So inside this for loop, what we are doing is, we are trying to compare our minimum element, which we have assumed to be 40 in this case. We are comparing it with the value of j. What is the value of j? I plus 1. Let us go back here, which means this is my minimum element. I am trying to compare it with 20. Then, if I find that my minimum element is greater than a of j, as in this case, minimum is greater than the j value there. So I will update the value. Because see, when I am comparing it means what? Minimum value is greater and jth element is smaller. If I compare 40 and if I compare 20, we have assumed 40 to be the smallest element. But when I am comparing 40 and when I am comparing 20, I get to know that 20 is my minimum element and not 40. So I need to update the value of what? The minimum element. So instead of assuming that 40 is minimum, I will update it that 20 is the minimum. After this for loop, we have another if condition. Okay, this if condition, if you just look at this code, you can say that this is for swapping. We need to swap these positions, no? We need to swap the position of 20 and 40, right? So for that, we'll make use of the temporary variable and we'll try to swap it. Is this much understood? All of you here? Those two? Let's proceed now with the tracing. See how I have written. These three things belong to the outer for loop. But how the execution happens? We execute these two and then we get inside this, the body of the for loop, right? So likewise, I have just color coded here. If you observe, this is the for loop and here is the increment of that for loop. Then the second for loop, this is the second for loop, the J for loop, right? So here the increment is here because within the body of the second we are having the if condition. And this is the last one, the last if condition for swapping. Let's start now. For I is equal to 0. Have a look here. For I is equal to 0, we need to check for I less than n. So 0, what is the size of the array? Look once again, the size of the array is 6. So 0 less than 6. It is true. We need to update the value of minimum now. We will assume the value of minimum element is equal to the ith element. I is here. I is equal to 0. So I is here at the 0th index. Okay. Now I am saying that minimum is equal to I. So what will be the value of minimum? 0. It is going to be 0. Next, we did this, we checked for this, it was true. So we executed this. Now we are in this for loop. We need to update the value of j, which is equal to I plus 1. So what is going to be the value of j? 1. Next we need to check the condition is 1 less than 6. Let me show you the program. We did this. Now we are getting inside our for loop. Okay, we need to check this condition. So tell me what is A of minimum? That is 40. So 40 greater than A of j. 20. So if statement is true, we need to update the value of our minimum element, the j. So value updated of minimum, which is equal to j, will be what? 1. We need to update the value of minimum, which is equal to j, which is 1. So here we assume 40 to be minimum. Fine. We assume 40 to be minimum at 0th index. We checked for this, then we checked if 40 is greater than 20, which is true. If it is true, we can't say that 40 is the minimum. We need to update. Now 20 becomes the minimum element. So the index of j was pointing here. So that is going to be updated here. So this will be equal to 1. Correct? Did I write it here? J plus plus? Sorry. So this will not come updated in minimum. So we are done with this. What will execute now? J plus plus. j is going to be incremented. So what will be the value of j? It was 1. We need to update it to 2, increment it to 2. Next, j becomes 2. We check for less than 6. Now, a of minimum. See, minimum value is updated here. So what will be? 20 greater than 60. False. So if it is false, we need not execute the if, right? But we need to increment j. Let me show you. This has become false, but we are still in the for loop. So we need to increment. So j will become 3. Check for 3 less than 6, which is true. Then a of minimum 20. Here 20 greater than a of j. J is at index 3 now. The value is 10. 20 is 20 greater than 10? Yes. So if it is true, we need again to update our value of minimum. So what will be the value of minimum? Equal to j. What is the updated value of j? 3. So this will be 3. Next, we increment j for 4 less than 6. A of minimum now. A of 3. 10. 10 greater than a of j, which is 4. 50. False. So no need to change our assumption of minimum element, but increment the value of j to 5. So 5 less than 6, which is true. A of minimum now. 10 greater than 30. False. No need to assign, right? Increment 6. This becomes 6. So the condition here becomes false. So no need to go in the body of the for loop. No need to assign this. No need to increment again. Now, this portion is over. Soon after this execution, we need to execute the if. Okay. Now check if minimum. What is the value of minimum? Here. Index 3. Okay. So 3 is not equal to I. What is the value of I? Is not equal to 0. Then we need to swap the elements. Swap what? A of I. Tell me what is the value of A of I? 40. What is the value of A of minimum? 10. So we'll write the updated values here, 10 and 40. Correct? Let me update the array. We swapped A of I. A of I is A of 0. That was 40. We swapped this element with A of minimum. See, the minimum is 3. A of 3 is 10 and that is to be swapped with 40. Did the minimum element come to the lowest index? Yes. But this is just your first pass. In bubble sort also you had not. This is just your first pass. Only I is 0. Okay. Now, let me go back again. This if portion is over. Which is the next code that is going to be executed? I plus plus. So I now becomes equal to 1. I becomes equal to 1. Check for 1 less than 6. So again assume the minimum element to be equal to the value of I, that is 1. So we are assuming that 20 is the minimum element now, after 10. After 10, 20 is the minimum element. So this is going to be equal to 1. Go inside the for loop for j, update the value of j, which is going to be equal to 2. Check for 2 less than 6, which is true. Check for a of minimum, that is a of 1. What is it? 20. So 20 greater than a of j, 60. A of j is 60. So let me show you the updated value here. Here, we are here. This is the first iteration. Okay. In the second pass, the value of updated j is here. Have a look here. So it is 2. So a of 2, which is 60. So 20 greater than 60, which is false. So no need to change the assumption. 20 is the minimum element. Next, we not change this, but we need to increment j. So j becomes, write the updated value, check for 3 less than 6, which is true. Again, a of minimum 20, a of j 40, false, no need to change the assumption. No need to change the assumption here. Increment 4. Check for 4 less than 6. Now, check for a of minimum 20 greater than a of, yes, it is 50. Again false. No need to change the assumption, but increment j 5. So 5 less than 6, which is true. Check for again 20 greater than 30, which is again false. No need to assign. Increment. So now when this becomes 6, this is going to be false, right? Now, if this is false, where do we execute now? This block, right? Let us check. So tell me the minimum value. 1 not equal to the value of I. The value of I is 1. False. False. So we do not have to swap, no? Why are we not swapping? Because the assumption that 20 is the minimum, which is the second lowest element, is at the correct place. That is why in the second pass, we need not have to swap it with anything. The assumption was right. Now, which is the next lowest element? 30. Let us go for the next pass here. Let me write this as second pass. Now, what will be the value of I? 2. Check for 2 less than 6, which is true. What is the next statement? You have to assume a minimum element which is equal to I. So I am assuming that this time 60 is the minimum element. So what will be the value here? This is the for loop here. Okay. So j is equal to I plus 1. Value of j 3. Check for 3 less than 6, which is true. Check for a of minimum. A of 2. 60. Greater than a of j 40. Then our assumption we need to change, because 60 is not the minimum element. So minimum becomes equal to the value of j, which is 3. You need to increment j. So what will be the value of j now? 4. Check for 4 less than 6. True. Check for A of minimum. Check. (40) greater than A of J. J is 4. 50. False. No need to go for this, but 5. Check for 5 less than 6, which is true. Check for A of minimum. 40 greater than 30. True. If it is true, we need to change our assumption. Now the minimum element to be assumed is 5. The value of J will be 5. Increment 6. 6. Here 6 less than 6 becomes false. So no need to execute these. What do we have to go for now? The if. This block. So the assumption here is, you tell me the minimum element again. What is the minimum element? Index value again. 5. 5 not equal to I. The value of I is so if it is true, what do we have to swap? A of I. A of I 60 and A of minimum 30. I need to swap this 30 with 60. In the third pass, did the third lowest element come to its correct place? Yes. Now the array is sorted, right? But for the homework, you can continue with this iteration and see at what iteration it becomes false and when the loop stops execution. Did you all follow? Students who are online, you can ask any doubts and also drop for the attendance. The same program for quicksort. Okay, I've put it in my home folder. Inside the home folder, I have another folder called DS 2021. So first thing is I need to come to this directory. So for that we use the command cd. Next, let me go for the compilation. So no errors. How many elements for quicksort? 5. Okay. Tell the elements. 20, 17, 30, 10 and 45. Are they in sorted order? No. The output is in sorted order. Fine. Let's check for selection sort also. How many elements? Tell the elements. 40, 20, 60, 10, 50. One more. Sorted order.